Welcome to Science with Mr. Weber. Today we're going to be looking at just some general principles surrounding organic compounds and finishing off that first section of the HSC syllabus for organic chemistry. Okay, so the shapes of molecules when single, double, and triple bonds are formed. So let's start off with our triple bonds here, so our alkane. Okay, so when we've got that single bond, okay, what ends up happening is you've got the potential for your hydrogen atoms to be positioned in several locations. Now, for example, let's say that we had two chlorine molecules. So you might have one down here, but then you could have one up here, or it could be over here or here. So that gives you a lot of options for different angles in which they could be relative to each other. So you've got a lot of room for variation there. Okay, the shape of this molecule is also tetrahedral because of the arrangement of bonds here. Now, if we have a look at ethene, so our alkene, we've got less choice than with our alkane. Okay, but we've got a flatter, planar shape that's being formed here, and now we still have the same ability to have that chlorine at different angles. Okay, it could be on the same side. The cis or trans. Now, that does mean that we can have some different locations there, which can lead to differences in the way they might react or interact with each other. Okay, but overall, less options than our single bond there. And finally, our triple bond, okay, our ethyne, our alkyne, okay, you have no options, and overall it's very linear in its shape. Okay, if you were to have this bonded to carbons instead, you're going to find that you've just got a straight line in terms of how that shape is going to take place. Okay, so dispersion forces. So just reviewing this quickly. So dispersion forces, or London dispersion forces, are the weakest intermolecular force. So it's caused by temporary interactions. So when you've got electrons and adjacent atoms occupying positions that make it form temporary dipoles. Okay, so what that means is you've got an uneven distribution of your electrons here on your helium. Okay, and so you end up with one part being overall negative and one part being overall positive, which will have the effect on the next atom over, okay, causing an induced dipole and causing, so let's say you've got an absence of electrons around here, okay, you're going to see electrons from this atom on the right here moving over and causing these two atoms to come closer to each other. Okay, now that is only temporary, but because you have so many particles present within a solution, you're going to find that overall there is going to be general attraction between them as a result. And these are forming and unforming at a very high rate. Okay, so we wouldn't really be able to observe that anyway. Alright, so melting and boiling point of alkanes. So now it's really important that we relate our intermolecular forces to each of these physical properties. So the melting point and the boiling points of alkanes increases with chain length, and the underlying cause there is the increase in dispersion forces. Alright, so the longer that this chain can get, okay, the greater the chance that it has with neighboring molecules, okay, to attract each other to each other. And what you see is they're going to be more tightly packed. You're going to have more energy involved there, which means it's going to be more difficult to break those apart, even when you're applying heat. And so that's why when you have a look here, see smaller molecules are sort of liquids under 0 degrees, okay, but then above, once you've got pentanes, once you've got 5 carbons there, you're starting to see a significant amount of dispersion forces in play, and you're going to see it's more difficult to have those break apart and form into a gas. Alright, so the safe handling and disposal of organic substances. Go ahead and pause the video, have a read of the information here on this chemical summary. Have a good read through it. So look, in terms of dealing with organic substances or a lot of these carbon-based substances, is that you will find that a lot of them are toxic. Okay, they might be highly volatile, meaning that they'll evaporate very quickly. Okay, they might be flammable, they may irritate lungs, and they probably can't go down the drain. So it's really important that you have a read through this slide, really get your head around that. Okay, so environmental implications of obtaining and using hydrocarbons. So issues with obtaining hydrocarbons. Okay, so we're going to be getting our hydrocarbons mainly from fossil fuels, so oil spills, that can lead to a lot of damage to ecosystems there, habitat destruction, fracking and purification processes. Okay, so these can release unwanted volatile organic compounds, and this can be really harmful to organisms. Okay, so you'll find that they will end up with respiratory irritation, and it is carcinogenic. Okay, it can lead to cancer. So issues with using hydrocarbons. So the CO2 that's released by combustion, okay, leads to that enhanced greenhouse effect. Coal power stations produce sulfur dioxide as a byproduct, causing acid rain. Motor vehicle combustion produces nitrogen dioxide, okay, because the temperatures within the engine are high enough and you've got atmospheric air sitting in there, and so you're enabling these to react. And plastic pollution, okay, because it's very difficult to break plastics down just in the environment. Okay, so the economic implications of obtaining and using hydrocarbons. So economically, the use of hydrocarbons has been positive overall. Okay, increased spending, number of jobs, greater access to energy. Economies can be vulnerable if they are too reliant on hydrocarbons, especially energy. So what I mean by that is it's so effective that, well, what's really going to replace that if you did run out or if there was a shortage? Okay, transportation, our transportation systems just wouldn't exist the way they do. And plastics, okay, I mean the computer that you're watching this on is made of plastic. The electricity that's running it, the light's coming from probably a coal station somewhere. Okay, so really there's a really big impact on the economy there. Okay, so sociocultural implications of obtaining and using hydrocarbons. So positives, so advanced pharmaceuticals, okay, efficient and affordable heating, electricity is readily available, and extended working hours as a result of that. I mean, being able to work beyond daylight hours. Okay, now the negatives. So normalized energy demanding lifestyle. So we get very used to this, and really it's been quite a sudden change for humans, and I guess we haven't really had a chance yet to see what those effects are, or I guess we do see that in issues such as insomnia. Extended working hours, so no longer are you able to say it's the end of the day, stop working. Now it's very common even for teachers to be receiving and sending emails or work throughout very late hours at night. Communities located near fracking and refining may be vulnerable to health issues and water contamination. Okay, so guys, that's it for the rest of that first section of organic chemistry. Thanks for watching. I'll see you next time.